today is Nick Tulloch, the CEO of Mendell Helium. Nick, great to be speaking again. How are things?
Very good, Mark, and hopefully you are well too.
Yeah, absolutely. Well, I assume you're very good because of the news you've put out this morning from the company. So you're saying that the flow rate has been measured now at 250 MCF today, so 132% increase. So I think before you were circa 100 MCF and circa $1,500, but that now takes you effectively to around $3,800 of helium production a day. So that's a good bit of news, isn't it? And unexpected from reading the RNS.
It's unexpected in that we didn't expect it to increase as fast as it has. We always expected Rost to rise, but this well has doubled in volume in the last 2 months. In each of the last 2 months, we never thought we'd get to 250 this quickly. It's only been dewatering for 3 months, but what this is telling us is the dewatering has done exactly the job it should have done, and probably more so. I mean, we've got an incredibly powerful reservoir. So 250, and as you say, it's in monetary terms, if it stayed at 250 for the next 365 days, that's just shy of $1.4 million. That is what the well is worth at the moment. And it's still going, and you've got gas coming up through the tubing at the moment. So there's extraordinary power under the ground, which is we're absolutely over the moon. We really are over the moon on it.
And you say that as well, the well is now flowing even with the pump turned off, and that hasn't happened before during any of the operations. So that's clearly a good sign as well, then, isn't it, that you're getting off that pump earlier than expected?
I mean, it's an amazing sign. When we started dewatering Rost, there were 1,000 feet of water over the gas reservoir, so nothing was getting through that water. 3 months on, the gas is coming up anyway. So what we're seeing is that as we dewater, the power and the pressure of that reservoir is forcing more gas to surface. Yeah. We ran the well for an entire day, or for an 8-hour period, with no pump. Yeah, and we were still getting more gas at surface than we were really able to properly deal with. So there's a huge amount of power under the ground.
So now you remove that pump that's submerged because it's going to overheat and it's not necessarily needed anymore, and you replace it with you call a beam pump, which I think is the traditional nodding donkey type pump.
Yeah, it's exactly right. When we started Rost, if we go back a year, we had a nodding donkey on top, and our single biggest pump actually was at Rost, and that wasn't enough to remove the volume of water that needed to be removed. So we put in the ESP that could remove 1,800 barrels of water, or 1,800 barrels of fluid, I guess is the right expression, per day. But what we're now finding is there is so much gas in the water, we're mostly pumping foam, which is good in terms of, we're gas producers. It's bad for the ESP. The ESP sits a mile underground, and it relies on a flow of solid water to cool it down. That is the only cooling mechanism. And so if you don't have that solid water, you run the risk that the ESP is going to overheat. And we're already seeing issues with that. So the smart move, there's a little bit of sort of work to be done here, but the smart move is we pull the ESP out of the hole. We can reuse that ESP on the next well we drill. There's nothing, ESPs can be reused in different wells. We already have the beam pump on site. I mean, we never removed it. So back together, that will now operate Rost. The good news is it's cheaper to run, uses less electricity. It's also a more conventional piece of equipment. So pumps do need maintenance from time to time. It's a lot easier and cheaper to maintain a pump that's sitting on the surface that you can touch and see and access, rather than something that's a mile under the ground. So overall, this is good news. Small caveat, we have to do a bit of work we weren't expecting to do, but we'll be doing the work with a smile on our face, because this is something we never thought we'd be doing as early as this.
As early as this, yeah, okay. And just on the dewatering side then, so that's not something that has to constantly be done, or is it something that is more important in the early stages, generally speaking?
It's more important in the early stages, but our expectation is it will be constant. I mean, we ran the well, let's say, for 8 hours without the pump and produced a huge amount of gas. We didn't run it for 8 days or longer to see how long that phenomenon would last. I mean, the fact it happened at all, the fact that it happened for a few minutes was extraordinary. The fact it was a few hours was absolutely amazing. So we're expecting to keep on pumping, and the beam pump we have on site is the most powerful pump we have. So we're still expecting to remove a lot of water. That hasn't changed. We're still using disposal well. That hasn't changed. But what we're seeing is, because the water is just now so foamy and so gassy, an ESP is just not suitable. It's just not the right piece of equipment to use. But the ESP, I often say to people that the single most expensive piece of equipment we ever bought as a company is the ESP. So actually to take it out and sort of, for a short time, wrap it in cotton wool and reuse it elsewhere is not a bad thing, because it's now just made our next well a little bit cheaper because we already have the
ESP. Yeah. And the Nodding Donkey, that beam pump, timeline to get that resituated?
Well, it's in place already. It's going to be a couple of days' work.
Okay.
So you pull the ESP out and then reinstall the beam pump. So it will be a couple of days. Aiming to get it done this week. We're sort of hurtling towards Christmas. Yeah, everyone gets a whole lot busier, but we have a couple of contractors who say they can do it this week. So it's not a long process. Yeah, as to that, there'll be a very, very short pause in production. I mean, fairly obviously, whilst the well's been worked over, we'd have it shut in. But it's a pause that, as I say, we're more than happy to do, because this is going to have a good effect on the economics. And as I mentioned, we have a very valuable ESP that can be used elsewhere.
Good. Excellent. And just on the increase then, the flow rate, and of course the increase in the revenue that will generate, from when we've spoken before, the bottleneck, I think, was the compressor. So you've got an increase in what's coming out, but are you able to actually sort of monetize that, or is that still a bottleneck problem?
We'll be able to monetize it in time. We're obviously very focused on getting all the helium out. What we have found with Rost is, I said, we never expected it to perform this well this quickly. This is a nice problem to have. Rost is 5% helium. The other 95% is largely waste. We'll get a little bit of value out of the NGLs, the liquids. We probably won't get much value out of the methane. Maybe less.
Sure.
With that 95% as fast as possible. And if you imagine our plant at Rost has a number of different stages. So we're taking out the hydrocarbons, we're taking out the water, we're then separating the gas into helium and other constituent parts. Every one of those stages will have its own bottleneck. So if we can remove that 95% or some of that 95% as early as possible in the process, we allow everything else to run as efficiently as it can. The compressor will not be a bottleneck once everything is in place. I mean, the compressor can probably do around about 60 MCF a day into the tube trailer. So if you imagine that 60 MCF is the 5% remaining value, so long as we're getting the other 95% out before the compressor, and that's the process we're putting in place at the moment, we have a very solid and very robust system. We've said on a few occasions that Rost has attracted a lot of interest. We've had interest from industry partners, but we've also had interest from engineers. We've got a number of meetings that we've had and are still having to talk about different solutions to just basically in more stages in the existing process. We're not about changing what we've got. This is more about sort of building more stages in to remove that waste at an earlier stage so that everything else runs a whole lot more efficiently. Now, again, a bit like the beam pump, this is something we always expected to do. Probably didn't expect to do it quite as fast as this. And again, I said before, we're doing the work with a smile on our face. The same applies here. It's a nice problem to have. And what it means is just accelerating some of the surface works that were always planned to ensure that we can deal with the volume of gas, which is frankly a lot bigger than we anticipated. Good.
So the discussions that are going on is really about sort of streamlining the process. I don't know if you call it a flow sheet or something like that. In order to reduce the bottlenecks along the way and get you to a higher purity product faster.
Yeah, I mean, exactly that. I mean, if you imagine what's coming out of the well, we have helium, which we want. We have hydrocarbons, which we can take out the liquids. Hydrocarbon gases, we'll come back to that with Bitcoin mining. We've got water. So there's different stages of the process that will take out some of these constituent parts, ultimately leaving the helium, then goes into the compressor and goes into the tube trailer and it is delivered for sale. So it's just about building more sort of modular units into the system to take out waste. Just as you do in any industry, you don't want to be dealing with 95% waste, so you remove it as you possibly can. And the good news for us is 85 of that 95 is nitrogen, so there's no issue just allowing that to vent into the air.
Absolutely. And could it be that then all the modules could work together across different wells, or would it be like you get a plan and you basically replicate it across different sites?
A bit of both. We are building the Rost site, or sort of continuing to build the Rost site on the basis it could cope with more than one well. So if a future well is close enough, the existing Rost facility will be big enough and robust enough to deal with more than one well. Same applies to the disposal well, by the way. The Broby disposal well was always designed with more than one production well in mind. So we're future-proofing the process as we go. But the first step is to make sure we've got the different modules in place. And as you can imagine, if you talk to engineers, everyone's got their own idea, everyone's got their own favourite brand. And as a company, we're pretty cautious not to rush into the first conversation we have. But I think we've honed in on exactly now how we want to set up the plan. And I say it is a sort of a linear process. It removes these different waste items. And there's further meetings this week, for example, on site. So this is not a long piece of work. It's a piece of work that's happening faster than we thought it was. But there's no complaints there. This is a really nice place to be.
Good. Well, it sounds like things are going much better than expected. So just to finish off and just to be clear on that increased flow rate, does that mean you're filling the tube trailers quicker now, or does that mean the gas is sort of being stored and backing up in a buffer as it goes through the various components?
A bit of both. We do have ground storage on site. We are certainly filling fast. We've got terrific pressure coming out of the ground. So the actual operations are doing as they should. But we need to scale up. That's the near-term task. But I don't want to present that as a problem. This is a nice situation to be in. We know how to scale up. It's always been part of the plan. Just as removing the ESP was always part of the plan. I just don't think we thought we'd be doing it in December. We thought it'd be some point next year. Good.
Excellent. Well, thank you very much, Nick Tulloch, the CEO of Mendell Helium, for your time today. Do you think we'll speak again before Christmas, or is it time to wish a happy Christmas now?
Let's see how we go. We've got a few conversations happening with industry partners. One of which in particular wants to try and reach resolution, certainly this side of the new year anyway. And these are people who would work with us on future wells. As I say, Rost is exciting to us, but it's also exciting to people who are driving past, thinking, what on earth are these guys doing, taking all this water out of the ground, and big pumps are appearing on site. So we're getting a lot of interest, and I guess maybe watch this space as to what happens next. But we can say Happy Christmas just in case.
Just in case. All right. Well, Nick Tulloch, Happy Christmas, and thank you for your time.
Happy Christmas, Bart.
If you enjoyed this interview, then give us a thumbs up, a like, or a retweet. Subscribe to us on YouTube or follow us on Twitter, and hit that notification bell to be the first to know when we release new content. There's loads of great content on our website too, across all our programs at stockboxmedia.com. Thank you for watching.